When we imagine the Middle Ages, we tend to think of Gothic cathedrals, illuminated manuscripts, and perhaps the power of the church dominating every sphere of life. But behind the theology and politics, there was also the night sky. Astronomy was not only the science of the stars, but also a language through which medieval people understood God, time, and power itself. Observing the heavens provided calendars, fixed a liturgical year, and allowed rulers to claim legitimacy by aligning themselves with celestial order. Yet astronomy was also a field of tension, where pagan legacies of Aristotle and Ptolemy met Christian theology, where Islamic advances filtered into Europe, and where the exact measurement of time became a tool of authority. As historian James Hannam has argued in God's Philosophers, published in 2009, the Middle Ages were not a period of scientific darkness, but of gradual accumulation and transmission of astronomical knowledge. And the cosmos was not merely a collection of stars and planets. It was a divinely ordered hierarchy. Astronomy was one of the 7 liberal arts taught at medieval universities, alongside grammar, rhetoric, and logic. It shaped theology, reinforced political authority, and bridged Europe to the intellectual achievements of the Islamic world. By the end of this video, you will fully understand how astronomy shaped religion and power in the Middle Ages, moving from monastic observatories to the courts of kings, and from cathedral schools to the streets of Baghdad and Toledo. How the combination of theology, cosmology, and politics made astronomy central to medieval power structures, and as we shall see, its influence extended far beyond the cathedral cloisters. In the medieval imagination, astronomy was inseparable from theology. Along with Dionysius Exiguus from the 6th century, Bede the Venerable, writing in the 8th century, became one of the most influential figures in this context. His treatise, De Temporum Ration, on the reckoning of time, provided a systematic guide to calculating the calendar, combining biblical chronology with astronomical theory. Bede did not see a conflict between faith and science. Rather, he saw the study of astronomy as a way to understand God's creation more deeply. The calendar reform was a specific and central political and religious issue. The calculation of the ecclesiastical calendar, the computus, determined when Easter and all dependent feasts occurred, so errors in lunar and solar reckoning had immediate liturgical and political consequences. The Synod of Whitby in 664 CE was convened largely to resolve conflicts between the Celtic and Roman traditions of calculating Easter, which were based on different lunar cycles. The eventual adoption of the Roman method demonstrates how astronomy shaped religious uniformity and ecclesiastical authority. Liturgical observances hinge on the position of equinoxes and the paschal full moon. The Julian calendar's 365.25-day year accumulated an error of about 1 day in 128 years. So by the later Middle Ages, the vernal equinox had drifted away from the canonical date of March 21st. When ecclesiastical and civic life relied on synchronized feast days, the drift produced pastoral and administrative strain. Calls for reform intensified in scholarly circles from Sacroboscian tractates. Johannes de Sacrobosco, a scholar, Catholic monk, and astronomer who taught at the University of Paris, wrote on calendrical needs in the 13th century. Fast forward to 1582, and Pope Gregory excised Intergravissimas. There we find the culmination of centuries of astronomical struggle with the introduction of the Gregorian calendar. Pope Gregory XIII, guided by the Jesuit mathematician Christopher Clavius, sought to correct the drift of the Julian calendar that had caused Easter to creep out of alignment with the spring equinox. The reform was not merely liturgical, but also political, as Protestant states initially resisted what they saw as a papal imposition. Thus, astronomy directly intersected with confessional politics, reshaping the rhythm of European society. The technical roots of this controversy were medieval. Astronomy was not confined to monasteries and universities. It was a tool of kings and emperors. Court astrologers and astronomers were tasked with charting the heavens, not only to predict eclipses or track comets, but also to legitimize political authority. The concept of the Rex Imago Mundi, the king as the image of the cosmos, meant that rulers often drew upon celestial symbolism to justify their reigns. Charlemagne, crowned emperor of the Romans in 800 CE, established a palace school that placed great emphasis on the quadrivium, the higher division of the liberal arts, of which astronomy was a key component. Alcuin of York, his chief advisor, argued that knowledge of the heavens was indispensable for governance. By demonstrating mastery over cosmic order, rulers could present themselves as divinely sanctioned. Later monarchs also employed astronomical spectacle to reinforce their power. The appearance of Halley's Comet in 1066, recorded in the Bayeux Tapestry, was interpreted as an omen of William the Conqueror's victory at Hastings. Here we see the dual role of astronomy and astrology in medieval politics. The heavens were both a source of empirical data and a stage for divine messages. The Holy Roman emperors, especially Frederick II of Hohenstaufen in the 13th century, went even further. Frederick maintained contact with Islamic scholars in Sicily and sought translations of Arabic astronomical texts. By doing so, he not only strengthened his intellectual authority, but also demonstrated the cosmopolitan reach of his empire. Astronomy thus became a weapon in the competition between papal and imperial power, with each side vying to present itself as the true guardian of cosmic knowledge. The physical study of the heavens in the Middle Ages was often centered in monastic communities and cathedral schools. Monks were among the most diligent observers of celestial phenomena, not only because of their liturgical needs, but also because they saw astronomy as a form of devotion. The rule of St. Benedict emphasized order and rhythm, and astronomical observation provided a framework for the canonical hours of prayer. One striking example is the work of Gerbert of Aurillac, later Pope Sylvester II, in the 10th century. Gerbert introduced the armillary sphere to Western Europe and was instrumental in reviving the study of astronomy based on classical sources. His reputation as a scholar was so great that later legends accused him of practicing sorcery, a testament to how closely astronomy and esoteric knowledge were associated in the popular imagination. Cathedral schools in Chartres and Paris also cultivated astronomical study, often drawing on translations from Arabic sources. The 12th century Renaissance, as it is sometimes called, was marked by a rediscovery of Ptolemy's Almagest and the works of Islamic astronomers like al-Battani and al-Zarqali. These texts provided more sophisticated mathematical models of planetary motion, which were integrated into the Christian worldview through scholastic commentary. Instruments such as the astrolabe became central to both teaching and observation. The astrolabe allowed for precise calculation of celestial positions and was used to determine prayer times, measure latitude, and even assist in architecture. Its widespread adoption in Europe illustrates the practical as well as symbolic power of astronomy in the medieval world. The medieval West did not develop its astronomical knowledge in isolation. Instead, it was profoundly shaped by cross-cultural exchanges, particularly with the Islamic world and Byzantium. After the fall of the Western Roman Empire, much of Greek scientific knowledge survived in the Byzantine East and was later transmitted through Arabic translations and commentaries. The House of Wisdom in Baghdad, founded in the 9th century under the Abbasid Caliph Al-Ma'mun, became a crucial center for astronomical research. Scholars like Al-Khwarizmi, whose work on algebra also influenced European mathematics, produced detailed astronomical tables that were later translated into Latin. Al-Battani refined Ptolemy's measurements of the solar year and planetary motions, and Izij al-Sabi was widely studied in medieval Europe. Al-Zarqali, c. 1100, in Toledo produced improved instruments and the Tolden tables. Nasir al-Din al-Tusi, 1201 to 1274, led the Marag Observatory and developed the so-called Tusi couple, an ingenious geometrical device used later in the history of astronomy to eliminate certain Ptolemaic eccentrics. The influence of Islamic astronomy was not purely technical. It carried with it a vision of the cosmos that blended science, philosophy, and theology. When these texts were translated in Toledo and Sicily during the 12th century, they enriched European scholasticism. Figures such as Adelard of Bath and Gerard of Cremona played pivotal roles in this transmission, bridging cultures through their translations. Byzantine scholars also contributed to this flow of knowledge. After the fall of Constantinople in 1453, many Greek manuscripts and scholars migrated westward, fueling the Renaissance and laying the groundwork for the eventual Copernican revolution. Thus, medieval astronomy cannot be understood without acknowledging the global networks of knowledge that sustained it. If astronomy was the science of the heavens, astrology was its more controversial twin. In the Middle Ages, the distinction between the two was far less pronounced than it is today. Astrology, grounded in the belief that celestial bodies exerted influence over earthly affairs, was widely practiced and often employed by rulers seeking to reinforce their legitimacy. One of the most influential texts was the Tetrabiblos of Claudius Ptolemy, which offered a systematic framework for astrological prediction. This work was eagerly absorbed into medieval scholarship, despite theological concerns about determinism and free will. Thomas Aquinas, 1225 to 1274, for instance, acknowledged the influence of stars on the material world, but insisted that human will remain free. He accepted that celestial bodies could incline corporeal nature, but insisted that intellect will lie beyond physical determinism. This nuanced position allowed for medical and agricultural uses of astral calculation while rejecting fatalistic readings that denied moral responsibility. Meanwhile, Roger Bacon emphasized mathematical astronomy and instruments as keys to natural knowledge, while still acknowledging astrology's influence in certain practical spheres. The result was a plural intellectual landscape. Theology constrained the metaphysical ambitions of astrology, but social and professional practice, physicians, court astrologers, kept many astrological techniques alive. Nevertheless, political leaders often leaned heavily on astrology. The coronation of emperors, the timing of battles, and even the foundation of cities were sometimes determined with reference to the stars. Richard II of England, for example, employed a personal astrologer, and his reign was suffused with celestial symbolism. Astrology also played a role in popular culture, shaping medical practice through the doctrine of iatromathematics, which linked the positions of planets to human health. This fusion of astronomy, astrology, and medicine demonstrates how deeply the heavens were woven into the fabric of medieval life. While medieval astronomy achieved significant advances, it was also constrained by the weight of tradition. The Ptolemaic model, with its system of epicycles and deference, remained the dominant cosmology. Even as observational discrepancies mounted, scholars often preferred to multiply the complexity of the system rather than challenge its geocentric premise. Theologians, too, reinforced these limits. The Aristotelian view of a finite, geocentric universe fitted neatly with Christian theology, which placed humanity at the center of creation. To question this was not only scientifically daring, but also potentially heretical. When Nicole Oersma in the 14th century speculated on the possibility of Earth's rotation, he couched his arguments carefully, emphasizing that such a model was only hypothetical. Yet within these constraints, important progress was made. The Alphonsine tables, commissioned by Alfonso X of Castile in the 13th century, represented one of the most ambitious astronomical projects of the Middle Ages. These tables refined planetary data and were used by navigators well into the Renaissance. They also provided the empirical foundation upon which Copernicus later built his heliocentric model. By the late Middle Ages, astronomy was poised on the brink of transformation. The scholastic synthesis of Aristotelian philosophy and Christian theology had provided a stable framework, but cracks were beginning to show. The rediscovery of ancient texts, the influx of Arabic knowledge, and the rise of humanism created fertile ground for new ideas. Textbooks such as Johannes de Sacrobosco's Tractatus de Sphera, circa 1230, became standard classroom texts. The tract simplified Ptolemaic cosmology for generations of students and ensured that a Ptolemaic, mathematically informed cosmos was taught across Europe. The invention of the mechanical clock in the 14th century also reshaped astronomical thinking, emphasizing precision and regularity. As timekeeping became more exact, so too did expectations for celestial models. By the 15th century, figures such as Regiomontanus were calling for a fundamental reform of astronomy, anticipating the Copernican revolution of the 16th century. Yet it would be a mistake to see medieval astronomy merely as a prelude to modern science. It was a discipline deeply enmeshed in the structures of its time, shaping and shaped by religion, politics, and culture. As historian Edward Grant has argued, the medieval synthesis created the intellectual scaffolding upon which modern science was later constructed. Astronomy in the Middle Ages was far more than a technical science. It was a language of power, a bridge between heaven and earth, and a framework for understanding both the divine and the human. From a liturgical calendar to royal legitimacy, from monastic observatories to Islamic scholarship, the study of the heavens permeated every aspect of medieval life. But the medieval legacy is not simply technological transmission. It is also an intellectual culture in which natural philosophy, theology, and political power were enmeshed, and where the pragmatic needs of liturgy, medicine, and statecraft shaped what astronomy meant. The controversies of the early modern period. Galileo's trial is the best known, must be read against this medieval backdrop of intertwined expertise and ecclesial authority. As we look back on this period, we see that astronomy was not simply about stars and planets. It was about meaning, order, and authority. In the words of Dante Alighieri, who placed the stars at the climax of his Divine Comedy, L'amor che muove il sole e l'altre stelle, the love that moves the sun and the other stars. In the Middle Ages, that love was understood as both divine and political, a force that bound the cosmos together and gave shape to human society.